Hello everyone, welcome back to the inflection point. In the last lecture, we discussed about the inverse functions, in which we built on the idea that when we interchange the variables x with y, we can obtain the expression of inverse function. And also building on that very same idea, we learned how to sketch the graph of an inverse function, and it is just the mirror image of the given function along the line y is equal to x, right? And we also discussed about something which is called restricting the domain. So if the function is not one-to-one and we need to find out its inverse, so we will find out some domain wherein the function will be either increasing or decreasing, meaning where the function is one-to-one. We will search for that domain, and using that concept we will find out the inverse of the trigonometric function, which is our next topic. So inverse trigonometric function, as we know that trigonometric functions are all periodic functions. They all are periodic functions, meaning after a certain interval of the angle, their value keeps on repeating, right? Meaning that all trigonometric functions are many to one, right? On multiple inputs, they get a single output. So how to find out the inverse of these trigonometric functions? So this we will learn in this lesson. So we will first start with the very first trigonometric ratio, which is sin x, right? We also learned about the notation of the inverse function, which is written as f inverse x, right? With the value of, not value, with just this number -1. And we do not read as f raised to power -1. This we all have discussed. So inverse function of sin x will be written as sin inverse x, like this. Okay, so now let us first draw the graph of sin x. So this is our axis, x and y, and we are dealing with the real numbers of x, meaning the radian angle we will keep, and sin x graph is something like this. Okay, in the positive direction, this value is pi by 2, this value is pi, and this is 3 pi by 2, and this is 2 pi. Okay, and in the negative direction it will go like this, right? Something like this. Okay, this value is -pi by 2, and this is -pi. This upper value is 0, 1. If the coordinate I need to write is 1, so I just write +1, and this value is -1. Okay, so this is a graph of sin x. Now as you can see, if we perform the horizontal line test, it will intersect at multiple values, right? I have just covered the period from 0 to 2 pi, and also from -pi to 2 pi, you can say, but in this period also it is intersecting at 2 points. So this is a many-one function for now. Okay, so as I said earlier, we need to make this function as one-to-one. So we will search the domain in which the function is one-to-one, mean it passes through the horizontal line test, right? So we can find out one interval is between -pi by 2 to +pi by 2. As you can see, between these two values, the function is one-to-one. After pi by 2, the value again keeps on decreasing. So it will again reappear. Any value between -pi by 2 +pi by 2 will reappear between the interval pi by 2 and 3 pi by 2. So you can take either interval -pi by 2 to +pi by 2, or you can take another interval pi by 2 to 3 pi by 2. Both these intervals will make the function a one-to-one function. Fine. But the norm is we will take that interval which is the starting interval or whose magnitude is small. It is difficult to deal with 3 pi by 2. It is rather easy to deal with just pi by 2, and same goes with -pi by 2. Okay, so what we will restrict its domain from -pi by 2 to +pi by 2. So let me erase this graph, and we'll just concentrate on the portion of the graph which is lying between -pi by 2 to +pi by 2. Remember, we are dealing with the graph of just the sin x, not the inverse function. We have first make the domain of sin x as -pi by 2 to +pi by 2, and then thereafter we are now in a position to find out the expression or the meaning of sine inverse x, right? And as we know now, if you need to find out the graph, sketch the graph of sine inverse x, so how we will do? We will draw a straight line which is y is equal to x line. Okay, so it is the mirror image. Sine inverse x will be the mirror image of the graph sine x between these two domains. Okay, so let me draw the sketch for you. It is like this, so it will go, sorry, this is a rough sketch, so pardon my drawing, like this. I hope you can see this graph of sine inverse, this black one. Okay, so let me mention this with sine inverse x. So black color is for sine inverse and red color is for sine graph, right? Now, what are the coordinates of these endpoints? As we knew from the last lesson that when we take the mirror image of any function in the line y is equal to x, the points, the coordinates interchange. X becomes y and y becomes x. So now, if this point is pi by 2, comma 1, okay, so counterpart of this point is this one, right? So its coordinate will be 1 comma pi by 2, right? So this value is plus, this is pi by 2. Of course, this 1 is less than this coordinate 1, which was of the sine s graph. This will lie lower to the value of pi by 2, right? Similarly, this point was minus pi by 2, comma minus 1. So counterpart for this will be minus 1 comma minus pi by 2. Again, the coordinates get interchanged. Okay, so this is about the graph of sine inverse x. So let us discuss about the range and domains of the function and its inverse. Okay, this is very important, right? So once we have defined the graph sine x, once we have restricted the graph sine x, let fx is equal to sine x, and if x belongs to, what is the domain? This domain specification is very necessary in order to have some meaning of inverse. If there is no domain for sine x mentioned, then it doesn't make any sense for finding out any expression for sine inverse x. Although there is no such expression for sine inverse x, but graph of sine inverse x, it doesn't mean anything if the domain of sine x is not mentioned. So domain is restricted from minus pi by 2 to plus pi by 2. Okay, if this is defined for sine x, then we are able to write that there is some sine inverse x also, such that, remember from the definition of sine of any inverse function, that when we compose, right, when we do some composition of sine with sine inverse or any function with its inverse, you get the same output. So sine inverse of sine x is equal to x, right? Remember, this is only valid when x is lying in the domain of sine x, meaning this x should be between minus pi by 2 to plus pi by 2. If this is outside the domain, then we will bring that angle inside the domain. What I mean by this, we will do some examples, then it will be clear, right? So for now, this is defined, and also its other side is also possible, that sine of sine inverse x will also be equal to x. But remember, this x is different from this x, right? In this x is the angle, but this x is the value of sine. Okay, now one more thing that I need to mention, that when we learn sine x, so in this x, in this function sine, this x is the angle. So angle is the input and output is some value. Okay, when we learned about the inverse function, this sine inverse x, this basically is an angle, right? Remember, in sine x, x was the input. When we do the inverse, that means the output will be the angle. So this sine inverse x, which is your output, that basically indicates an angle, right, at which the value of sine is x, right? So this x is the value, right? So for example, if I say that I know value of sine x is half, so what is x? So we write this as x equal to sine inverse half, right? So here this x is the angle, but here this x, I mean this is angle, so this angle, this should also be angle, meaning sine inverse half is an angle, and input those to sine inverse is the value. Input to the sine inverse is the value, right? So we read this sine inverse x as that this is I mean the sine at what angle will give the value as x. That is the meaning of sine inverse x. Okay, fine. So this was about sine inverse function, and this is the graph of this, and x and y got interchanged. This we have learned. Okay, let us come to the second trigonometric function, which is cos x. What about the cos x? Again, cos x is many to one, so how we can make it to be a 1 to 1? So again, let us draw the sketch of cos x. So cos graph starts from 1. It goes like this. Okay, and in negative also it goes like this. I mean, it is again a sinusoidal curve, but there is a shift, phase shift we say, of pi by 2 between sine and cos. So this value is pi by 2, sine cos pi by 2 is 0, cos pi is very important value, cos pi is always -1, right? And this value is 3 pi by 2, and we get the complete cycle at 2 pi. Okay, this is 0, this point is plus, and this point is -1, right? So as you can see here, again we need to make it a 1 to 1 function. So I can see clearly that from 0 to pi the function is a 1 to 1, right? And it looks like to be an easier domain to deal with. Okay, so we define cos x first between, so x belongs to 0 to pi. So erasing all these values and just concentrating between 0 and pi, so we get the curve of cos x between 0 to pi like this. Okay, now we need to obtain the inverse function. So let us draw y is equal to x line. Again, please pardon my sketch, it will be a rough diagram, right? So its inverse will be something like this. It goes like this. It goes okay. If you can see the mirror images of this black graph with the red graph, I think it's feasible. Okay. Now let us concentrate on the coordinates, because coordinates are important. Okay, so this point, if I say this point is 0 comma pi, so corresponding to this point in the cos inverse x, cos inverse graph, we get this point. So coordinate of this point will be pi comma 0. 0 comma, not pi, this is plus 1, I'm sorry. So this point is 0 comma 1, so we get 1 comma 0 here. Okay, so this point is 1 comma 0, right? And this point is pi comma -1, so I obtain this point as -1 comma pi. So the x coordinate is -1 and y coordinate will be pi. Okay, one more thing, in sin x I forgot to mention the domain also, right? I mean, we did not play with the domain and range of sin x. Let us talk a bit here also, in this also, that the domain of sin x is from -pi by 2 to plus pi by 2, and that becomes the range of sin inverse x. Okay, and sin x, so that becomes a range, meaning sin inverse x will lie between minus pi by 2 to plus pi by 2. This you should remember. And from graph also you can verify that the lowest value of sine is minus pi by 2 and the highest value of pi is plus pi by 2. Just concentrate on the y coordinate, not on the x coordinate, right? And the input of this sine is from minus 1. The leftmost x coordinate of the graph is minus 1 and rightmost is 1, right? So between these two values, so this is the domain of sine inverse, which is minus 1 to 1. So range of sine x, which is minus 1 to 1, becomes the domain of sine inverse x, which is between minus 1 to 1 plus 1. Okay, obviously these domain and range will get interchanged, and these you can verify on the graph. So same thing we can verify in cos x and its inverse graph. Okay, so cos inverse x. So if fx is cos inverse x, so here this x is the value, meaning the domain of this will lie between which is the range of cos x. So it is from minus 1 to plus 1, right? And this cos inverse x will lie between 0 to pi, as this you can see in the graph. Uppermost value is pi and lowermost value is lying on the x-axis, which is 0. So 0 to pi, right? Domain is again from minus 1 to plus 1. Fine. And here also cos inverse x, cos x is equal to x. I mean the composition will always be true even for tan inverse x also. And this is cos of cos inverse x is equal to x. This x you get always, but here this x should be between minus, for the case of cos x, it should be between 0 and pi. Okay, if it is lying outside this range, we need to bring that angle within the domain of 0 to pi, because as we know from 0 to pi, we get every value of cos. Same goes with sine also. Between minus pi by 2 plus pi by 2, you get every positive and negative values of sine. Okay, it's a different thing that after 2 pi the value gets repeated, okay, in the same fashion, but obtaining the value of sine x, only 180 degree is sufficient for cos x also. And next graph is of tan x. Let us do it quickly. So for tan x, the graph of tan x is very simple. We know that pi by 2 and minus pi by 2 are the two asymptotes. Okay, so these two are the asymptotes of the graph, and tan lies between these two. The graph of tan x will be like this. Okay, something like this. So range of domain for tan x is, although the tan x domain is all real numbers and range is also all real numbers, right? Except the odd multiples of pi by 2. Except odd multiples of pi by 2, the whole real number is the domain for tan x. So that becomes the range of inverse function, right? But we will do later on. First, let us make it a one-to-one function. So I can see that from minus pi to plus pi by 2, the function is excuse me, the function is 1 to 1. So we keep this domain only, but excluding these end values, because it is clearly seen from the graph that at x equal to minus pi by 2 or plus pi by 2, the tan x is not defined, or it is minus infinity or plus infinity, right? So the domain, restricted domain for tan x is same as sin x, that x should belong to minus pi by 2 to plus pi by 2, except one thing, that these end values are not included. So using open bracket, we need to mention the restricted domain for tan x. Now we are in position to actually sketch y is equal to x line. This is y is equal to x. So having drawn this, let us obtain the mirror image of tan inverse x. So it will be like this and like this. Okay, so this is not the arrow. Yes, arrow I should draw, because it is extending to the plus infinity. I mean, this is going towards x infinity. Okay, it is never ending. And what are those values? I mean, it is not going to plus infinity, it is going towards the x direction of the infinity, right? So as you can see here, the input of 10x is from minus pi by 2 to plus pi by 2. That becomes the range of tan inverse x. So basically, if I draw the horizontal asymptotes, right, so these two lines are the horizontal asymptotes, which are basically minus pi by 2 and plus pi by 2. Okay, so these green lines, this is your minus pi by 2 line, and this is your plus pi by 2 line. So tan inverse x graph, this red one graph, will try to approach these two values. Okay, so tan inverse x, we have restricted the domain. So if fx is tan inverse x, here x, what will be the domain for tan inverse x? As you can see, all real numbers. Just like range of tan inverse x is all real numbers, that becomes a domain. So x is all real numbers, and tan inverse x should lie between, not equal to, minus pi by 2 to plus pi by 2, excluding these two values. So this is the range, and this will be the domain. Fine. Let us quickly mention, I'm not drawing the sketch of sec x or cosec x, I'm just mentioning the restricted domain for sec and cosec, right? As we know that sec is the reciprocal of cos, sec x is 1 over cos x. Okay, so whatever is the domain for cos x, I mean domain, whatever values we have restricted for finding out cos inverse x in case of cos x, same goes with sec inverse x also, right? Meaning is that cos x is involved, and we have restricted a domain of cos from x equal to 0 to pi, right, including these two domain. This is for cos x, right? But in case of sec x, you can see that wherever cos x is 0, sec x is not defined. Okay, so we need to exclude those values where this cos x is 0 within this domain. And from 0 to pi, there is only a single value, which is pi by 2, which is lying between 0 and pi by 2, at which cos x is 0, meaning at which sec x is not defined. So restricting the domain in case of sec x is same as restricting the domain for cos x, except that we need to exclude this point pi by 2. So we mention the domain as, for sec x, that this x should lie between 0 to pi by 2, excluding this pi by 2, and then from pi by 2 to pi. Or you can write from 0 to pi by 2 pi, just like cos x, but here just exclude the point pi by 2. Okay, this is also correct, and mentioning the domain like this is also correct. Okay, and then fifth is for cosec x, which is 1 over sin x. So applying the same logic as we applied for sec and cosec, so here x will be defined from minus pi by 2 to plus pi by 2, except those values where cosec is not defined, which is 0. Okay, so you can write the domain, restricted domain, like this, except 0. Or you can mention like this, that from minus pi by 2 to 0, excluding 0, union 0 to plus pi by 2. Okay, both these notations are valid. Okay, so that's it about the graphs and domains and ranges of inverse function, and how we can restrict the domain of any trigonometric function in order to obtain its inverse function. Okay, I leave the graph of sec x and cosec as your homework. If you want to sketch the graph of sec x and cosec, you need to first sketch the graph of sec x and cosec in order to sketch inverse graphs. Okay. Alright, so let us come to the questions which involve sine inverse sine pi by 3, for example. I mean questions based on sine inverse sine x or cos inverse cos x and so on. Okay, so let us do these type of questions and how do we approach this. Remember that in sine x, this x is the angle as I have told you, right? And sine inverse will again be an angle, right? The first thing we need to notice here that whatever angle you are giving to the inside function sine, this angle should lie within the domain, within that restricted domain. Okay, so restricted domain was, or in case of sine, was from minus pi by 2 to plus pi by 2, and this pi by 3 is lying in between these two domains. So here you can directly write the answer as pi by 3. Sine inverse sine x will be x. You can verify it. Sine pi by 3, we know this is sine 60 degree, meaning root 3 by 2, and sine inverse root 3 by 2 will again give you the angle as pi by 3, right? We can do this directly because we have verified that this pi by 3 is lying within the domain. This is very important and crucial step that you need to perform first in these type of questions. Okay, let us do the second one. The things will become more clear to you. In the second part, it says that cos inverse cos 3 pi by 2. Now this cos 3 pi by 2, as we can see, the 3 pi by 2 is pi plus pi by 2. I mean the value of cos pi by 2 is 0. Okay, so cos 3 pi by 2 will give you 0, and cos inverse 0, you should write 0 instead of 3 pi by 2. So we cannot directly write 3 pi by 2 just by reading this, that cos inverse cos x will always be x. So we should write cos inverse cos 3 pi by 2 as 3 pi by 2. No, this is wrong. We need to bring that angle within the domain of that, within the restricted domain of the function. Okay, so giving meaning to cos inverse x, giving meaning to this cos inverse expression is only valid if this angle is in between the restricted domain. Fine. So here it is lying outside. So what you do in these type of question is you evaluate the value of cos, whatever the angle is given to you, just like we did just now, that cos 3 pi by 2 we evaluated as 0, and now you obtain the angle such that cos inverse 0, you need to obtain this angle. That at what angle? Between 0 and pi, cos is 0. So let us say this angle is theta. So I am saying I need to find out this cos theta such that it is equal to 0 within the domain of 0 to pi. Okay, I hope it's clear now. I am repeating this once again, and you will get more questions, so I will repeat that concept again and again. So answer is not 3 pi by 2, answer is 0. Not 0, sorry, answer is pi by 2. This is 0, cos 3 pi by 2 is 0, and cos inverse 0 I will write not 3 pi by 2 but as pi by 2, because pi by 2 is lying between 0 and pi. Okay, moving on. Tan inverse tan 3 pi by 4. Tan 3 pi by 4, evaluate tan 3 pi by 4 as pi minus pi by 4. So in the second quadrant, angle is 45 degrees. So tan 45 is 1. So value of tan 3 pi by 4 is minus 1. So basically it is written as tan inverse of minus 1. Now check whether you can write directly as 3 pi by 4. As you can see, this is 0.75 of pi, and domain, restricted domain for tan x is same as sin x. Okay, because tan is written as sine over cos. You can remember like this also. So sine was defined between minus pi by 2 and plus pi by 2. So similarly, tan will be defined between minus pi by 2 to plus pi by 2, except one value. I mean, except those corner values. So this is greater than pi by 2. This 3 pi by 4 is lying outside the restricted domain, right? So what you do, you evaluate the value of tan 3 by 4 as minus 1, and now you find out that angle at which, the tan of which gives you minus 1. I should say like this, tan of which gives you -1, and this angle should lie between the domain -π/2 to +π/2. So if you write 3π/4 in the second quadrant, that will lie outside the domain. So basically the domain for tan inverse x is in the first and second quadrant, or sorry, first and fourth quadrant, like this. So this is the domain for sine inverse and tan inverse, not the domain, range. Okay, sine inverse x and tan inverse x, this is the range for sine inverse and tan inverse. And for cos inverse, we will deal with 0 to pi. So if the angle is lying in the third quadrant or in the fourth quadrant, we try to bring these angles in this domain. So the angle in the fourth quadrant will be written clockwise. Fourth quadrant angle will be written clockwise, right? As I think you know that if the angle I have written as -π/2 to +π/2, so minus angle meaning is you are measuring angle clockwise, right? So this tan inverse -1 basically is tan -45 in the fourth quadrant, and -45 is -π/4. So the final answer will be -π/4, and this -π/4 is lying in the domain. It should, and it has to, because we have built the concept like this. Let us come to the fourth part, which is sec inverse of sec 3 pi. It says sec 3 pi. We cannot directly say that it is 3 pi. First, understand the domain for sec x. We restricted the domain for sec x like this, from 0 to pi excluding pi/2. But here the input is given as 3 pi. It is lying outside the domain. So first let us obtain the value of sec 3 pi. Sec 3 pi is basically 1 over cos 3 pi. Sec 3 pi I should write like this, because I don't remember exactly the value of sec 3 pi. And now I know that cos 3 pi is -1. So basically sec 3 pi is -1, right? So it is written actually like sec inverse -1. And now I need to find out the angle at which sec is -1. So sec -1 is again at pi. Okay, so answer is pi. Sec pi is -1 because cos pi is -1, and this pi is lying in the domain. It is exactly at the end point of 0 to pi. So this will be the answer. I hope it is getting clear to you. If not, then please pause the video and try to think. Next is cosec inverse cosec of -pi. So cosec of -pi is minus cosec pi. Cosec of -pi is minus cosec pi. And what is minus cosec pi? It is -1 over sine pi. And sine pi is 0. That means it is not defined. So cosec is not defined, meaning this is not defined. So if the angle is not defined, I mean the value is not defined, so cosec inverse, what you can write? Between -π/2 to +π/2, at what value the cosec is not defined? If you write 0, that at 0 it is not defined. But please remember, this 0 is not in the domain of cosec. This 0 is not in the domain. So that where these functions are not defined, we have excluded those values. Okay, so do not write 0, or if something sec is given to you as not defined, okay, odd multiples of pi/2. So do not write answer as some odd multiple of pi/2, because that is not the part of the domain of sec x. We have already excluded those, problematic points. So answer is does not exist. Okay. Now the last one. This is very important. How to deal with these type of questions, wherein some trigonometric function is given to you, but inside its composition is given to you with some different inverse trigonometric function like this. It may be like this also, that sine is outside and inside it is cos inverse of some value 1 by 2 or so. So how to deal with these type of questions, let us understand. As you know, and please pay attention to this also, that the last question, outside is a trigonometric function and inside is the inverse function, right? Previously all these 5 parts, output was the sine inverse or inverse function and input was the trigonometric function, but here it is just the opposite. Okay, so basically this sine inverse 2 by 3, as we know that this represents an angle. Sine inverse 2 by 3 is an angle at which sine is 2 by 3. Okay, so if this is an angle, let us consider this as theta. Why we are doing this? Because we need to write sine inverse basically in terms of cos inverse, so that I can write cos of cos inverse as cos of cos inverse x as just x, right? These two trigonometric ratios must be inverses of each other. So sine inverse is not the inverse of cos, so we need to bring cos inverse, right? So we need to write sine inverse in terms of cos inverse. This is our basic task. So how do we do this is that you mention this sine inverse 2 by 3 as some angle theta because it represents an angle. So from this we can say that sine theta is basically 2 by 3, that there is a right angle triangle now in which there is an angle theta, the sine of which is 2 by 3, right? And using this triangle we can find out the value of cos theta. How we can find out? Sine theta is 2 by 3, so sine theta is defined as, from the basic definition of sine, it is opposite over hypotenuse. So opposite is 2 and hypotenuse is 3, so adjacent comes out to be, using Pythagoras theorem, as root 5, right? 9 minus 4 is root 5. So from this triangle I can mention cos theta as root 5 by 3, adjacent over hypotenuse. That means theta now comes out in terms of cos inverse as cos inverse root 5 by 3. Okay, so now we are in a position to evaluate our question. This is cos of sine inverse 2 by 3 and sine inverse 2 by 3, which is theta. This is also theta, that means this is equal to sine inverse 2 by 3. So sine inverse 2 by 3 I can replace with cos inverse root 5 by 3, and this will always be root 5 by 3. There is no doubt about it. There is no doubt about it. Why? Same goes with sine also. I mean, if the trigonometric function is outside and the input function is the inverse function, that will always give you this input x. No matter about that we need to bring that angle inside the domain. There is no problem in bringing any input value in this particular case within the domain and so. Why? If I write this as, let us say, sine of sine inverse root 3 by 2, for example. Sine inverse root 3 by 2, as I know, is an angle, and there is no doubt that angle you will mention this between 0 and between, I mean the acute angle you can give. Sine inverse root 3 by 2 is the principal value of the angle will be 60 degrees or pi by 3, and sine pi by 3 you will again give as root 3 by 2. There is no doubt about it, right? If you need to mention the angle, let us say obtuse angle, if you need to mention that sine inverse root 3 by 2, that no, it is not necessary that why should I give the acute angle only. Let us give the obtuse angle. So let us give this, let us consider this theta as pi minus pi by 3, let us say 2 pi by 3. Okay, so you are not writing this as pi by 3, rather it is 2 pi by 3. Sine inverse 2 pi by 3 is root 3 by 2, so I can write this as sine 2 pi by 3. So again you will give the value as root 3 by 2. Okay, so this in general, sine of sine inverse x will always be x. Same goes with cos also, always be x. Same goes with tan also, or any trigonometric ratio. So I should mention this as t of t inverse x is always equal to x. Okay, but T inverse of Tx is equal to x, not always. I mean, then we need to play with the domain. Okay, so its answer is root 5 by 3. So that's it. I think it's again is a very long lecture, but since we are dealing with AP calculus, everything needs to be studied in detail. So that's all for today, and I think the syllabus for pre-calculus is over. We have done starting from the basic quadratic equations, quadratic inequalities, right? Basic idea about the inequalities. Then we did about the functions also. What do you mean by domain and range? We did some questions also, graph of the functions, trigonometric functions, and inverse trigonometric function, simple inverse functions. What do you mean by inverse functions? So all these topics needs to be studied well in detail in order to start the calculus course, because basically calculus starts not from the limits, but it starts from the functions. First we need to have some basic idea of the functions, how the functions are behaving, what do you mean by domain and ranges, then only we can go further. So now, having completed the prerequisites knowledge for starting the calculus course, so in the next lesson we will start with the first topic of your calculus AB or BC syllabus, which is limits. Okay, so till then, bye bye. I think you have enjoyed the video. Please do comments in the comment section if you need any help, or how I can improve this lesson, if you want any worksheets, etc. And please mention in the comments, and please do like, share and subscribe. Thank you so much. Bye bye.